We're going to be going a little bit over of, I know we beat this to death. We're over PlantPAx, and they have just released version 4.6 that has some useful updates in it, and we wanted to go over some of that. So we're going to break it down, and this is how the test is going to read at the end of the class too. It'll be broken down to 8 sections. Section 8, the summary, will be a written answer. So what is PlantPAx? Well, it's very easy to say. It's just a list of, it's our faceplates and the code behind it. Well, when people approach it that way, things go wrong. Spoken from some people who've seen it before. There's a lot more things that go into it than that. So besides our faceplates and global objects, we have all these other tools and documentation to support our PlantPAx. It does seem a little daunting, but each one of these items, whether it's an online tool or a free software tool we give you down to the instruction set for it, it all means something. All the rules to what we're trying to achieve is there. We want to point out today what tools are out there and what we can help you to, we want to help you design and lay out these systems correctly the first time. Okay, with PlantPA 4.6, we do have some new process objects that came out, and we'll talk a little bit about those. When the Server 2016 support, which is a big deal. We Asset Center version 9, which also has a new backup agent. So if we're doing a redundant Asset Center system, it makes it easier to back it up.
Yeah, we'll back up the factory talk view system and the HMI system as part of the actual application.
Okay.
So one of the things that you'll see, and you guys, for anybody that has seen or known about PlantPAx, it's all about how we characterize the system, how we put the reference architecture together. So the system release 4.6 is a minor release. The 4.5 was kind of the major release that came out last, I think it was August, September timeframe. This came out early on, and I think it was end of April, May timeframe. What you'll see is we've now updated and tested it against version 31 of Studio 5000, the 2016 support. So it's all the documentation, everything that comes out along with it.
And part of that, because, and I got asked this question this morning, this is a little off the rails a little bit. What version are we pointing people at right now? Well, because PAX supports 31, the latest, as long as you're not having to support redundancy, we're telling people to go to V31 right now. When V32 is out a little bit longer, we'll go there, but that's where we feel comfortable at this time. 32
is the latest version. It doesn't support redundancy right now. So when we're talking about the L7 controllers, 31 still has redundancy support. It has all the documentation for the process side of it. So where we can, we're pushing you to 31. We still support 20, 24, and those discussions. But for everything new and anything we can, we'll push everybody to 31.
Okay. You want to talk to the objects a little bit?
Yeah, so we did release a new set of library objects. The question that we usually get when it comes to PlantPAx is, for a PlantPAx system, do you need to use the process library objects? The answer is no. Obviously, we did separate those out. But if you look at all of our documentation, we heavily use the process objects as part of our sizing utilities, how we do the HMI system, how we tie in with all of the tools. So if you want your life easier, you use the library objects, but they are not required. That being said, we came out with some new ones. So we had the 4.0 or the big major release. We went heavily into the kind of ISA 101 standards, a lot of grayscale. We went from a vertical layout to a horizontal layout. In the newer set, we just added a couple pieces in here. So an advanced interlock block, okay. For everybody on the phone, we just got like a call in. And then that's what it's, some improved sequence blocks and things of that nature. So there is new documentation that came out with the 4.1 objects. And it's one of those things that if you've seen it in Studio 5000 and inside of the process library objects, you're not necessarily required to use the latest and greatest, but if there's something that you can add there, you can import and export different versions of it. So if you're starting from scratch, obviously you download the latest library, put that all into your system. But if there's a feature set in the new library set and you're commissioning or you're supporting something that's older, there's a potential that you can just add that one object that you're missing.
Okay. With 4.6, we're now up to, we're supporting version 10 of SE. We'll go down on 5,000 as low as RS Logic's V18, which hopefully none of you would actually do. But it is there. And then we have some added some additional add-on profiles and some new hardware into our system. Those are the mins, right?
Right.
Oh, no, yeah. These are the mins. I figured our customer base would pick it up when I picked on version 18. Obviously, you're the only one who didn't.
Yeah, so we're going to push you to the latest, greatest. Documentation is on the latest version of Factory Talk. For the limit there, the SEME version 10, we're looking at the process library object, the new set. So that horizontal grayscale when we came out with the 4.0, the minimum version that you can be on there is 10. If you are still running Factory Talk View version 8, version 9, you can use the older file set of the library. So the 3.5 library set that we had is still available on the process download site. So the PCDC, you can go in there, just type in process library, and it'll give you, just like any firmware, it'll give you the options of what library to download.
Okay.
You get to hand it off now.
What's that?
I'll take it.
All right.
Cool. So like Mike said, as part of the test, so we're going to go through the elements. So realistically, some of the architecture pieces, I'm going to take it a little bit step by step as we go through. It is death by PowerPoint, but you came to a user group, so you can't complain. And we're feeding you. So the people on the phone, you should have come in.
There's a price to pay for that $6
So as part of the
sandwich.
documentation on the architecture, we're looking at now not just the controller set. So we're not concerned only with the controller and the IO. We're also looking at the networking pieces, the software that goes with, and how that ties in, including the power side of it. So we're going to be talking about the VFDs, the motor control centers, the field device implementation, all of it is documented as part of the PlantPAx system. So like I said, we're looking at it from a system level, not just the core products that we usually see. So typically when we are looking at the servers and the software side of PlantPAx, so not just looking at the controllers, we usually use the term PAS or PASS. So it's our PAS server, Process Automation System Server. For all of you guys in the know, it's basically the Factory Talk View SE platform, the data server, the alarm and event server. Those are the components that sit inside of that. So we're looking at how we would do a directory. So if it's a single server, we would have the Factory Talk directory, the HMI server, potentially the historian data interface, because we're pulling from the Factory Talk links connection, the alarm and events, and the data server. Traditionally, when we look at the documentation for PlantPAx, everything is located on one server. It's a simple setup. You spin up one Windows 2016 image, dump everything on there, either use our templates or you use your own install, and you have everything on one box. As we start growing and we want to do a redundant HMI system, we'll now have 2 PAS servers. We recommend that the directory no longer exists on those boxes. If I have a primary and secondary server, I don't want my Factory Talk directory, which should always be on, to be dependent on a primary and secondary. As we add to a bigger system, so if we're looking at a small, maybe 2,000 point IO system, traditionally we're looking at 1 PAS server, 1 alarm and events, 1 data server. As we grow into a system that's taking on a full setup, so let's say 10,000 points of IO plus, we're probably going to be looking at adding additional servers, additional clients. So what we can do in this size of it is we can go up to 10 redundant servers, and we can also start splitting out some of the requirements that are there. So if we just break it up into areas, if anybody's played around with Factory Talk View SE, you can create areas. Area 1, Area 2, Area Utility, Production, Packaging. Every piece would still have its own connection with the exception of the Factory Talk directory. As we mentioned, you want to leave that kind of on its own. If I don't care about the HMI side of it, let's say I just have more controllers, but I don't really have that many clients or many HMI screens that I need to worry about. Let's say I have 100+ controllers. Well, I'm going to ask you to separate that out into multiple data servers. There's no license requirements to add more data servers. Basically, a data server is just either OPC. So I'm looking at Modbus, I'm looking at OPC DA or OPC UA, or potentially Factory Talk. So the Factory Talk links is my data server. I can have 10 of those and I can make them redundant. So the requirement there is 1 Factory Talk links and 1 OPC per data server. So I can't stack them up on top of each other. And it's required on OS. So whether that's virtual or physical, you just can have as many as you need to. So a lot of the times, if you have multiple buildings, you might have a data server in each building. That way, if you lose connectivity, it's still running. The other application servers that you'll see, Asset Center, Historian, Vantage Point, SQL, all of those, traditionally speaking, are on their own OS. And then the other pieces that we might look at is the Microsoft piece. As you grow more than 10 computers, you're looking at a domain type system. So you have your Active Directory, the ability of being able to do remote desktop if we start talking about Thin Manager, and then also how you would handle patching. So on a traditional system, you just patch every single system. If it's a full virtual install, you might have 1 computer that's dedicated to do all your patching, all your antivirus. So all of that is documented in the stuff that we came out with 4.6. Going into a little bit more detail is how we do the pass. You would have, again, all of your pieces there. A traditional thick client is what we've done in the past. You have a Windows computer that you put out in the field with the operations side of it. You install Factory Talk as in the product, and that runs either on a single box, on a panel view, or potentially on like a quad screen monitor. Those are all physical like workstation boxes, Dell, HP, you name it. The other option is looking at it from a thin client environment. And at that point, there's no Windows operation system. It's a Windows server that runs on a server in the control room, either part of your install or a separate box. And that would stream a session to each individual piece. That could be a tablet, that can be a mobile device, or it could be a thin client. So we have one in the lab here if you guys haven't seen it before. And you can make them redundant. So the main idea here is if I want these 2 running, I want my operator never to see a fault if my primary server that's feeding the session of the remote desktop dies. From a controller point of view, I can look at simplex controllers, compact logics, or control logics. Both are acceptable as part of PlantPAx. Redundant controllers, if I'm looking at that, I'm looking at the control logics L71. I can do on the simplex side the L81. It has been tested and approved for PlantPAx. The big thing there is there's no redundancy. So if you need redundant systems, you're still on an L71 platform for at least the next year. And then non-PlantPAx controllers, mainly third party. We can accept communication from Modbus and anybody else that you're bringing into. We have tons of Encompass partners that can bring that data in. Once it reaches a Rockwell controller, it's a Rockwell point. I don't care how it got there. So as long as you're sizing accordingly for the amount of data that's coming into the system, that's all we're worried about. So if you give me the sizing of a PlantPAx system and then forget that there's 100 controllers in Modbus that you're bringing in, you didn't size it accordingly. So. System elements, so on the IO side of it. So obviously we're bringing in your standard information. Analog discretes, control logics, and flex are your defaults. Those are really realistically what we look to at the most. Point IO and everything else that we have is available. All of those are case-by-case basis, depending on if you need redundant IO, if you need intrinsic safety, those types. You can bring in HART directly into potentially almost every IO platform that we have. If you need to support either Profibus, PA, or Foundation Field Bus, we have a gateway product. It converts it over to Ethernet IP. So all of those feed directly into it. And then if there's any Ethernet IP devices, so whether it's E&H or anybody else, those will come in directly into the system. So those are all fair game as part of the system. And last piece here is the power side of it. So obviously, if we're talking about Modbus connections or anything else, those would come in just as standard I/O as we're looking at it. But if we're doing tie-ins, anything that is an Ethernet IP device from us, whether it's a PowerFlex 755 or 525, those are fair game. Those look like I/O to us. It's the same way that a static switch looks to us. And then anything else, they'll just require some type of gateway system on there. So the MCCs, all that power lineup side is also I/O when we look at the PlantPAx system. And this is more just for the fact that it'll be in the deck so you guys can see it. As of Factory Talk View version 11, we've increased the size of this. So if you guys want to take a challenge, you can build a system that's more than 120 clients on it. So I haven't seen any of you guys build anything that big, but if you do, I want to take pictures. Realistically, the 120 are the number of screens that you're looking at. The way that we license the product is the actual device that's hosting it. So whether it's a thin client box or a physical workstation, the license is incurred there. If it's 4 monitors connected to that, it's still 1 license. So the only thing that we care about is if you launch 4 clients on that 1 box, that goes against your 120 count, not against your licensing. So you guys have seen we have the SE bundle. It's 1 unlimited server, 10 clients, 1 viewpoint for 1 fixed price. So that's usually typically what we're looking at to do these type of systems. And again, if it's a thin client, even if it is the thin client that can host 7 4Ks, that's still 1 license. Character.
Okay. Everyone knows, everyone has memorized. We've always operated from the DDD methodology. I just made that up. By the way. So when we start putting together a PAX system, first of all, we have to define what we're trying to do, what we're trying to achieve. Then we go into the design work, and quite often that's what we do out on the distributor side. Myself and my counterparts, we quite often will take the raw numbers you give us based on your I/O counts, your design strategies, and we'll run it through the process estimator to see where we are and where we stand on it. To make sure that based on what you told us so far, we're getting all green lights and everything's good to go. Then we come into how to develop it. That's where we start creating
Move it up a little bit.
How about better? Okay. Whoops, did I go backwards? Okay, the ACM libraries, we start developing that. So when you start laying out your code, you're going to be reutilizing what you use on a regular basis. Then we come to the configuration where we actually start configuring some of the database that we've created for the system, then the deployment and the verification system. So that's the approach. And if you go into our PlantPAx users manual, you'll see it's laid out this way. This is how we want you to approach your design system. So this is also part of the documentation that's available for you to follow. Okay, when it comes to sizing checks, this is what we're trying to hit. This is what we're trying to achieve. Can we get a display up within 2 seconds? Or are we updating in a second? So these are what we're trying to do. And when we use the process estimator or the other tools, this is what we're shooting for as part of our process system.
So every single time you hear us say it's a characterized system, this is what we're talking about. So
this has all been tested too. So provided you follow our design guidelines. So a lot of you have run into this already. So we're covering this a little bit, but we don't need to. Everyone knows in an L7 environment, when you do a PAX, don't take it above 75%. Have we taken it up to 80% and it worked? Yes.
Have we
do we want you to do that? No.
And still said it's okay.
And that's a big chunk of that is the processor we're using. We're still using the L7s for this. This is what everything is based on. So we know we have overhead that we have to account for with that particular CPU. And anybody who's done a redundant system in a PAX system, this is always the gotcha. Don't run it above 50% on it.
One thing that you will notice is when we're talking about the PlantPAx system estimator and we're talking about the requirements on this, it's all sizing at an L7 level. So like I said, the L8 is fair game. The L8 will not follow these specific standards, but in terms of sizing and in terms of what we can do right now, we're gonna still show you the L7. Because of the fact that they haven't officially gone through and done all of that, that's gonna be the next iteration of PlantPAx. But for right now, when we're looking at this, the CPU and the memory become extremely important, especially in an L7 platform. The CPU is how we handle communication out. So if you go beyond that 70, 80% range, you're incurring into the communication realm. So at that point, that's when you start seeing a slowdown of your HMI. That's when you start seeing a slowdown of the processes that you're doing. Why it's so critical to make sure that when you're doing redundancy, don't go above 50%. We are planning for worst case scenario. And yes, if you get into the 50, 60, 70% range, it may work, but there's a reason why the warning is there. And that's mainly what the sizing tool is trying to tell you.
All right. And just some of the other things. I mean, we want you to break out your alarm and events server. So no more than 10,000 alarms on it. And then the number of tags on scan. This is all stuff that's very important. That's why you need to start dividing up the system when you start building it too big. So again, the process system estimator tool will help you lay out that system that way, because instantly you can tell pretty much when you're gone over the performance specifications of the system. Okay. I want to talk to this. So when we take a look at this, when we use the process system estimator, has anyone actually used it here before? Okay, so a lot of you aren't going to know talk about. There's multiple screens as you're laying out your I/O. Part of it, when you put it, you tell me that you have so many I/O points. The system's going to estimate how many visualization tags you're going to have there, how many alarm tags. It's all estimated. So knowing your control system and how fast the tasks are going to be part of the equation of how to come up with a good estimation of what we're trying to do. Everything again is based on the L7, so we have to take a look at both the motor control, which is separately, because those are all soft tags for the most part coming in, versus the hard tags and some of the other network. All come in a little bit differently, and all this is addressed in the process system estimator tool.
Yeah, if anybody tried to do it in the past, you were basically like taking a shot in the dark, because it wouldn't give you specifically an E300. So it didn't tell you how much memory or CPU utilization it was using for an MCC. Now it breaks out and you can actually say, okay, I'm going to define an MCC structure. It tells me all the devices that would be inside of that would be Ethernet based. And so you can put the full count, and that would go to the processor memory and CPU utilization.
Okay, this is actually some displays from the process system estimation tool. What you don't see is the bulk of this is you're laying out your I/O up here as part of your control strategy, and this is tied specifically to this block here. So as we define what our control system is doing with these I/O points, it's also giving us an estimated amount of visualization tags and alarm tags that are going to come along that we have to account for in the process system. So we're not really coming up with a lot of these numbers. It's based on the I/O count there. You can go back and modify it. Again, you can change it and there's also different control schemes you can do, whether it's this is a fast update system or you can go slower. You can actually adjust that through this pull down over here on this side of the block. You can also, instead of doing by I/O count, you can actually also lay it out based on what type of control strategy you have. So you can lay it out based on your update times on your scans and what type of code and we're using over here.
Yeah, one of the things that you'll see is when we do the sizing on PlantPAx, like I said, it's looking at worst case scenario. it will take some defaults based on the IO structure that you put in there. If you know your system well enough and you know, okay, I'm not going to be scanning it at 250 milliseconds, it's actually going to be 500, anything like that, you can make the changes and that will affect what the CPU and memory usage estimation should be. So don't necessarily take it just as a grain of salt. If you know what your process should be, this is going to be generic. So you can make the modifications. You can go in there and change your IO structure and what the tags will be. And that's how you get that calculation.
And then also, I guess this is just a little variation, and this is kind of new to me. We're taking a look at the Ethernet IP device, the soft IO points on Ethernet. So specifically, I guess this is more of an MCC application. So, and this is actually kind of a new addition to the process system estimation tool. I haven't had a chance to utilize this part of it, but it does address an issue I've always had, because we always have, one reason to use our system is we integrate with power very, very well, better than anybody. So this now, the tool is increased, so it actually gives us a better ability to take a look at the soft tags being driven by power equipment into our process system.
So one of the things that you'll see on the right-hand side, so there's that edit button. So again, for PlantPAx, you don't require the process library objects, but all our documentation and all our tools are built off of it. So if you want to use your own, you can go in there and edit it and replace that information with your own library. So whatever it is that you're using for your AOIs and things of that nature, and then plug that in and it will do the calculations for you. If not, if you happen to be using the 3.5 library, you can do the pull down and put the 3.5 library, because that one's assuming the latest and greatest. So those are the little things that you can go in there and just make modifications on based on what your system's doing. So our library is not required, but strongly recommended.
One thing I didn't address, and maybe I should, does anybody, do we know where this software actually resides? I know you do, because you said you've used it before. It's part of Integrated Architecture Builder. So it's in IAB, so if you already haven't installed it, it's there. If you go to the configuration tab on the right side, there's a wizard specifically for the process system estimator. Any of our specialists would be glad to sit down with you and go through some design work with you, build up a case system. Or if you ever want to do it on your own, there are labs available that are in the help section of IAB that will walk you through every component of this.
And don't be afraid to use the IAB tool in the PlantPAx system estimator for your standard projects. It doesn't necessarily have to be tied to a DCS application. The estimation tool that it gives you is pretty well off, that it gives you the information that you'll need, just the size of project, whether it's simplex or redundant. So we use it all the time on the specialist side and the Rockwell side to help the customers out when you guys are trying to figure out how much IO, what size controller. It is a good tool outside of just using it for PlantPAx.
Okay. And this is something new to me. I hadn't seen it before, was you can actually put your spare allotment of memory for future growth. The last time I did a system, that wasn't part of the update. I'm sure it's part of my system now when I take a look at it. So you can reserve memory and CPU. If you want to keep 10, 20% spare, just throw the number in there and you're good to go.
So you'll start getting the warnings on there. So like I said, it will give you warnings. It'll start turning things yellow. It'll start turning things red. Red is bad.
Yes.
So as you start seeing, to Mike's point, you can add spares, so you can account for your system growing 1 to 5 years, let's say. So you can figure out what the loading is going to be on your controller 3 years from now when you added another process skid. On the software side, I'm going to, every single time you add an IO, I'm expecting there's going to be alarms. I'm expecting there might be historian points. There's going to be tags on scan for the number of clients that you add in. So all of that will take into account what the loading will be on the controller. So as you start seeing those little yellow warning signs, you see your system is starting to grow large enough that you may start affecting the controller. And at that level, you get to decide, Is it a matter of increasing the memory on my controller? Is it a matter of adding another controller, another Ethernet adapter, or maybe just adding another data server? So those are the type of things that it's trying to answer for you.
And quite often, that's why you use the tool. I design until I'm told it doesn't work. Then it helps me go back and break up the system until it works. So it's a good way. It's always start off breaking the system, then go backwards. We're not doing this with real hardware, so it's cheap to do it. Okay. You want to address this one?
Yeah, so this is just showing you, again, all the things that you're being asked of if we're looking at the alarming. So, and again, in this case, if we're using our process library objects, an analog input has a potential of 5 alarms. Each one of those alarms, because of the ISA 18.2 alarming standard, also have shelving disable and everything else. And it's a tie-in to the controller. The controller becomes the master. So you're now adding about 15 data points that have to be recorded inside of that controller that are on scan as a potential alarm. So the reason why we give you a number of 10,000 alarms per data server or per alarm and event server is because of that. So as you start sizing it and you start adding analogs, digitals, and everything else, you're also making the assumption of how many alarms you're planning on adding into the system, whether that's through ALMAs, ALMDs, or the standard HMI alarming. So just be aware, that's the reason why we say it's worst case scenario, because it's gonna say, I'm going to plan for the fact that you're gonna add all of these alarms. You may only add half of them. So you guys can make the decision at that point, maybe I'm okay. The yellow warning sign is fine because I'm not gonna implement all the alarms. But if you do, that's the reason why.
That's one of the reasons in the process estimation tool, most people will call BS or something when they see it, because they see the number of alarm tags driven based on the IO count. And they said, there's no way I would ever do that many alarms. Well, in the real world, you wouldn't, but potentially that's what you could see. And we're designing to the potential. So who wants to answer this question? Number of potentials alarms used. I saw the slide, so I knew it was 100%, so I got it.
So yeah, so sizing on that is going to be based off what we're looking at.
Is code management, is this you?
Yeah, I can take it. So when we start looking at it, so one of the things as part of like the development side of it, so now shifting gears into like a Studio 5000, FactoryTalk View Studio environment, when we provide you the process objects, we're also providing you up to 75 control strategies. So normally when you're looking at it, you're talking about the little AOI structure. So just like your P alarm, your P analog, all of those pieces, we also provide to you the control strategies, which is the entire thing built out. So it's all the Lego pieces already built up for you. So it's the entire routine, essentially. So you can either build them from scratch, or you can use the stuff that we already provide for you. So all of that is part of the library. So when you download the library, you get all of it. There's documentation around how it should be used, when it should be used. You get to choose whether or not you do it. So for a lot of testing stuff, this is probably good to bring it in, and then you can start getting rid of it and then create the interface that you want. Because a lot of the times we'll plan out for everything. You may not need 2 of the pieces on it, get rid of it, save it, that becomes your template going forward. So you'll start seeing you got your analogs, your analog channels. What we recommend is every single one of your instruments, every single one of your sensors be on its own routine. So one of the things that you need to realize is the way that the processor goes through is if you create multiple sheets, it will go through every single one of the sheets before it starts over again. So it will launch every single one of the routines at the same time, but if one of the sheets has 200 sheets on it, your scan rate is going to go through every single one of those before it comes back, instead of launching all 200 of them at the same time. So we've seen that in the past. So those are things in the guidelines and the reference architecture that we're telling you about. So recommendation, each one of these might be a sensor, each one of these might be a pump, a valve, even just an analog or digital point. So for the process strategies, all you have to do is go into Studio 5000, do add, import routine, and you find all of the L5K files that are inside of the library. So you can kind of pick and choose which one you want. Once you do that, you have the option to create, overwrite, update. So all of those are there. You can do this while you're online. Do I recommend that? No, but you can do it while you're online. If there's any errors, if there's anything that it sees or anything that's already existing that you're merging into, it will find the collisions and let you know ahead of time what you want to do with it. Do you want to overwrite them? Do you want to merge? Or do you want to create a new copy? Maybe you already had XT101, you want to create XT102. And then you can go in there and do tag substitution on all of this stuff, just like anything normal that you've seen. And then it will create all the instances for you. What it's also doing now is it's adding in all the dependencies. So if you try to add in, let's say an analog block, but you forget to bring in the P alarm block beforehand, it will make sure everything is packaged together. So when you do the import, it'll bring in all the pieces that it needed anyway. So you no longer have a broken piece of code anymore. So that'll just automatically bring everything in, and all you have to worry about is how you name it. And then the other part you have to worry about is making sure you put your jump routine on it. Because I will be honest, about 50% of the errors are the code's just not running. It's in there, it's just not running. So, any questions so far? I'm about to take you guys on a little roller coaster ride. So if you thought I was talking fast before, this is about to get worse. Feel free to ask questions, and if I go too fast or something got lost, let me know. Configuration of this system. So like I said, we're working on Studio 5000. That's the development for the controller. We're looking at FactoryTalk View Studio for the HMI side of it. We're providing you the AOIs, the UDTs, that entire structure when it comes to the library objects and everything else. We are making the assumption at this point that you are using it, and I'm going to show you some of the tools that enable you to do this a little bit faster. So as we start seeing this, again, on the alarm side of it, one of the things that usually people forget about is the fact that once you add in our library, each block has a set number of alarms to it. So like I said, the analog block will have up to 5 alarms, low, 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 high, broken wire. Once you add that into the system, they will not show up in the alarm summary page, because you did not set them to be in the alarm summary page yet. All you did was you added them into a faceplate. So I will be the first to say that I'm sorry. That's kind of how it works at the moment. So there are tools in place. So there's something called an alarm builder. So it's a free tool. So again, as part of the library, if you open up the folder that says tools, there's an alarm builder. It's a little executable. It will run, it will scan your ACD file and find all the objects that you used. So again, if it knows what objects, and in this case, it's the plant and the process library objects, it will create an Excel file with every single one of the dependencies that would be part of it, and it will add it into the alarm summary page. So it's a big Excel file, so you get to create that within about 5 minutes. You don't have to do anything manually. So once you set it up, you just import it. You don't have to go in there and check the boxes and do all of that stuff. All of the defaults are set up by what you set. That includes the status tags and the controller tags. So now anything that you do from an HMI side of it, whether it's from the alarm summary or whether it's from the faceplate, all of that writes back to the controller. So this is all you have to do once you scan it in. And I won't go into detail, but it basically creates a big gigantic XML file in the background. Some of the other tools that exist, so FactoryTalk Historian 6.0 came out. We now have that as part of the list when it comes to PlantPAx. That uses what's called asset framework. Inside of that, again, if you're using the process library objects, we can then start creating the structure of the alarm or the historical points that you'd be looking at, and that would be automatically brought into the asset framework infrastructure. So now you'd be able to not only see just standard data points like you do normally, you'd be able to see the entire structure of a P and like a motor block or a VFD. And you can pick and choose which points you want, and it would be able to save that into the system. Looking at that. Now, we've talked about this in the past. How many people have used Application Code Manager? You don't count. You count a little bit. So Application Code Manager, really quick, it's our bulk code instantiation. It's what we use for PlantPAx. Most of the demos that you run with us will show Application Code Manager to get you started. It is free to download and free to use, especially if you use our library objects. If you plan to use your own library objects or your own stuff, there is a license fee to it. But to do everything that I'm about to show you, it's all free. So download it, there's no excuse. What this does is it creates a project, it sets up your library, and then it generates the code. But it's not just code for the controller. It's also for the HMI, the historian, and the alarms. So as we go through, this is kind of the layout that you'll see for Application Code Manager. On the left-hand side, you'll see the system view, so what components you're planning on using, what your tree structure looks like in the controller. The right-hand side is the libraries that you have registered under your name. So that's not only the process library objects, the machine builder libraries, and if you have the licensed version, it's your own libraries. If you have the paid version of this, you can have it off on a server and have all your engineers tied into the exact same database. If it's the free version, on your laptop is where everything resides. So kind of difference there. So as I go through, I would tie into my process system library. It gives me all of the library objects that exist. So that, again, you download this off the product download site. All of this sets up an Application Code Manager. You create new and you set up the library that you're doing there. It tells you what version is currently launched on your system. It will also allow you, as you add things in, most of you have started a Studio 5000 file from scratch. There's nothing in the AOI blocks. You either use a template, you use an old piece of code and start deleting stuff. If you use Application Code Manager, the library will have anywhere from 60 to 80 different objects. You probably only need 8. If you only need 8, as you build this out, it will only take the dependencies that it requires. So your code will only show the pieces inside of it that you actually pull in. So it takes care of that part for you. As you start doing that, then you can start seeing all the different pieces that you're creating as part of the library. So as I add in, this is a basic analog block, all the defaults. So same thing, if you've ever hit the little ellipses on the side of it and gives you all the defaults there, you can change it inside of the code. You can change it inside of the FactoryTalk View client window. This is up front. This is setting your defaults. So when you create a new analog block, all the defaults will come with.
Rockwell did something really cool here, where they took all of our blocks and condensed them into one, and within Application Code Manager, each one of those selections actually kind of whittles down what pieces of code get put into your system. We did a little research on how this is all done, and it's about 30,000 lines of XML code. So there's a lot of attention to detail in that block, making something like this work and work very efficiently with all those different variants. If I was going to create this myself, I probably would have just made 10 different versions instead of trying to combine all 10 into one and doing all that XML code. But
Leave it to Joe to try to backwards engineer the thing. For the most part, this is what we've all been doing in coding world with XML in the past. This is putting everything together for you. So thankfully now there's a program off the shelf that you can use instead of us building something out. So the next step on this thing is it will build out your logic. So again, you're looking at it from your routines, your task, everything that's there. You're setting the default so it knows where you want to stick it. So if you're using an analog input, more than likely you defined it to be either the 250 milliseconds or the 500 millisecond rate. So it's automatically going to move that in. You can do generate partial. In this case, if I want to create and go into the task and say, I'm going to add a new routine. So you hit new, it gives me the list of all of these process strategies that we were talking about. So again, if you wanted to use what we have from scratch, this is going to include the entire thing. So it's going to include all the different pieces on it. If you choose, in this case, the example here is, again, an analog input. You give it the name, you give it the description. So that is being requested of you. All of the rest of it has been the defaults that you set. You get to choose which analog input you want to use. So as part of the process library objects, it's not just one. You have a dual input, multi-input, you can do an average. So you can pick and choose which one of those you want. You get all the defaults that go inside of that. Then when you're looking at the I/O configuration, you have your input PV, module fault, and channel fault. You can go into the type of controller that you're looking at, the I/O that you've structured, and you can tell it what physical I/O points you're actually looking at. So that'll build out and give your entire setup. So again, from the configuration side, you're taking a little bit of time to configure everything up front before you start your code. But once it generates, all of that, those tie-ins are already there. Now you get to say, okay, again, an analog input has 5 potential alarms. I don't want to turn all of them on. I want to turn this guy on, which is high alarm. As soon as I do that, it triggers all the configuration for that one block. So I can go in there and start making the modification. If I go in there and turn on another one, it will then go and turn on the configuration for that one alarm. So this is going to be tied into the same type of alarm builder tool that I was talking about, but this is embedded inside of application code. Now comes the, not just the controller, but the HMI. If I want to look at the HMI side of it, I have 2 options. I can either do a panel view or I can do factory talk view SE. So it just depends on the size that you're doing, but the library exists for both. So in this case, I'm doing SE. I've already defined as part of the configuration where my SE server resides, what the factory talk directory is, and this might be on a laptop that I'm doing for configuration. I can also tell it, okay, once it's tied in, this is everything that's there as a default. I can choose my graphics. So an analog input block has an associated process library object faceplate. So this is tying that piece in. And then I can choose which element block I want to display. So if any of you have seen the process library, you know we give you options. So an analog input isn't just a bar graph, it could be a trend, or it can be just the value. What we've done with the latest iteration of it, anything that you see blue is a changing value. So if you see it black, it's a static point. If you see something blue, it's a changing value as part of the ISA 101 kind of high performance stuff. So you get to choose which one of these it's creating. It's not going to go in and tell you exactly where it's going to lay it out in the screen. What's going to happen, it's going to create one screen with every single one of these done. So when you open up your development, all you have to do is drag and drop to where you want it. But all the connection points have already been made for you. So now we're looking at, we got your tie-ins for your I/O, your alarms, your graphics. So again, you're creating the project, you're bringing in your library, and then you're generating the code. The other option is you can also do inside of the library object, there's a Excel tool that allows you to do an import-export function. So application code manager can synchronize. So you can open up a piece of code and synchronize it to application code manager. So if something was already written, you can see the defaults and the parameters that are there. So as you make changes, you can synchronize those changes back and forth. You also have the ability of opening up this Excel file that sees all the library objects that we're using. The first tab on there also tells you how to use your own library. So again, by default, we're using ours. And what this does is mainly for bulk code. So imagine having 100 tanks and you don't want to go into each one of them because you forgot it was 0 to 10 feet, not 0 to 12. So you don't want to do that through the code. You can do that through Excel, drag and drop, and import export. So that allows you to start looking at this, and this ties in and scans out your system, tells you exactly what's on there. So this ties into every single one of the little blocks that you put in, ties into everything that's there, and you're basically just copying and pasting everything on the side. You can also create systems inside of application code manager. So it's not just our library objects, it's the creation of the library objects. The example that they always give is the clean in place. You can also do boilers and everything else that you can think of. Mm-hmm. So we made things easier for you and you still wanted to go a step further to get your coffee. So for anybody on the phone, basically, one of the things that we're also doing is we have a command line interface and the ability of being able to script. So that is extremely powerful, and it's something that came out as a version 3. So right now, again, it's a free download. You pull that from the PCDC. So while you're getting the library objects and you go in and just put process library objects, also look at application code manager and download that. We can provide you guys labs. We do have cloud-based images that we can use to get you guys trained up. So if you haven't used it and you want to start, let us know. We'll get you started. We bury you in documentation. That's the joke that I always use on the Rockwell side. With PlantPAx, the 4.5 release was even worse because we added in about 4 or 5 different documents that you have to read. If you use the PlantPAx system sizing tool inside of IAB, basically it's taking into account all the manuals. So one of the things that you'll see is there is an infrastructure guide. So as we start looking at not only the VM sizing, but also how we do the layout of the VLANs, your networking, your tie-ins between your core and your access switches. We're looking at the CPU memory sizing. So that's kind of the key feature that we need to make sure that we hit our characterization. And then how we look at the servers. So whether it's a physical or virtual server. So once you put a PlantPAx system, how do you make sure that you fit all the little parameters that you put in there? So one of the easiest things is we provided you a verification checklist. It's a PDF document that has an Excel list on there, and you use that as a tool to test against your system. And it will give you warnings, and it will give you big red X's if you did something potentially wrong. So if there's any type of buffering system or anything that you're seeing, you are seeing these tools, and everything would be included as part of the system. So it's free, you download it, you can go to the knowledge base, or you can download the PDF document. So after this, like you guys have seen, you guys will get an email, you'll have the PDF of this presentation. We're unfortunately recording it, I think, so you have to listen to me twice. But you can get that and just download it. What this will look like is the Excel sheet will have all the different pieces on it. So you'll see the system infrastructure, how you gave names to the servers. For anybody that has played with a FactoryTalk software platform, you know that naming conventions are very important, and not changing the names after the system has been in place is very important as well. Don't ever change names. System architecture, how you're doing your layout, what the utilization is, things of that nature. And how you set up your HMI server. So where you have your directory, where you have the alarm and events, all of those bits and pieces. How many displays are you using? How many clients are you using? And then tie into the controller. So a lot of this will tell you how to get the information. Some of it is just going to be a visual. There's a little faceplate that pops up on the HMI, and it does all the readouts of system variables. You type that into the Excel, and it automatically does a macro to tell you where you are. Last couple of pieces before I let David run and kind of show you what this should actually look like. So like I said, PlantPAx is our characterized system. It's been out for years now. Typically, we're looking at systems anywhere from 2,000 to 10,000 points of I/O or more. It is a redundant system. It scales from a process skid environment using compact logics all the way to a full redundant system with multiple controllers. And we take it from cradle to grave. So pretty much everything on your site can be owned on the Rockwell side. And we have tie-ins to all the third-party stuff as well. One of the things that you guys have access to, a majority of you, is the virtual templates. So every major release, and in this case, minor release of PlantPAx, we release a set of virtualized templates. So that would be a tie-in where you can look at that. If you share, we should still be able to see it, David. So what that does is the PAS, it's a Process Automation System Server. It's a virtualized template now running on Windows 2016. We provide you a hard drive. It has a virtual template that you can dump into VMware or Hyper-V with the Windows operating system and the actual application already preloaded. So it doesn't have any of the code that you would set. That's your job. All we're doing is setting the guidelines so you don't have to install anything from scratch. No more DVDs or Blu-rays or anything like that fun stuff. We give you one for each one. So as of 4.6, we released a full set of images that are all running on 2016. We also came out with what's called a PAS-C. So it's a PAS consolidated. So instead of normally telling you run every single one of these applications separately because it's a big system, if it falls within a set guideline, so no more than 2,000 points of I/O, no more than 10 clients that you're connecting into, we've now tested it against all the software being on one operating system. So when we look at this, we provide, everything else has been provided as a .ova file. So it's just a virtual template. This guy is provided as an ISO file. What that means is you can run it on a physical server. So if it's a smaller system and you're just running a Dell tower, you run the ISO file and you replace the operating system that was on there with what we provide. We are expecting you to use a Microsoft volume license. So you would either use your customer or your own MSDN license to be able to activate this. It doesn't have Rockwell licensing and it doesn't have Microsoft licensing to begin with. If you want, you can buy the Rockwell part number for the license of that image, and it'll have all the pieces in there, especially like think of an engineering workstation. It might have Studio 5000, FactoryTalk View Studio. You can buy one license key and it activates everything that's there, or you can use the regular licensing that you buy any other time. We do have a full lineup for cybersecurity. So as we get into this, it's a passion of mine. So get me into the conversation, I'll talk you through it. But a lot of times what you'll see is the L8 processor is now certified for 62443. We now have the SIP security that we need to talk about at the user group here. That's been out now, so that gives you an ability of being able to do encryption. And as we start looking at it, we are providing documentation when it comes to cybersecurity on supporting kind of like your basic cybersecurity hygiene. So there's documents that we have out right now in PDF format that you can see how should you handle username and passwords, how you should handle open ports on a switch. All of that is tied in, and what they're planning on doing is setting up an application white paper directly for PlantPAx. So that's in the works. They're currently doing that. We've had little snippets come out here and there. So if you guys can't find anything or you need to go a little deeper, just let me know. And just kind of going back to it. So we're looking at how we deploy the system, how it ties in, and looking at it from a holistic approach, not just the controller itself. Sit on my side.
Okay, you hear it? You hear me okay? Okay, I'm gonna share my screen. Okay, Brian, let me know if am I good? Okay. Okay, so we decided this week or this month that we'd try to do a little bit hands-on for you guys as a little kind of a little extra. So this is our first attempt, so we'll see how it goes. But what I'm gonna do here for the next however long you guys can be here is I'm gonna actually go into a PlantPAx system and kind of show you how to start one up and show you kind of the basics of starting from scratch, what the routines look like, what it looks like in FactoryTalk View, Logix 5000, et cetera. So before I get started, a little more background. So what I'm actually running on Rockwell Automation's cloud-based training system. So everything that I'm doing today, you guys could actually do at a later time if you wanted to. And this training, I think, is called the PlantPAx Application Development Module. So this is pretty basic, but it just gives you a good idea. And we thought this may be a good thing to try today. So we just got through, hearing the latest and greatest. I'm not going to include Application Code Manager on this. That is more of a bulk, sort of a specialized thing, and Joe covered that a few months ago. So I'm not going to do that, but I'm just going to start with the basics. And on the cloud, we do have an emulate controller running. So I do have that running. Sometimes emulate on the cloud and virtual is a little dicey, so I've got my fingers crossed. But hopefully things will go well. So what I'll do, I'll go ahead and just get started. So I've got Logix running. So this Logix program, I don't know how well you can see it, hopefully better than me, but this is using the what we call the basic library template of PlantPAx. So it's, it's standard basic Studio 5000, but there's a couple of little sort of foundations that it creates for us. If you look here on the controller organizer, you've got a set of predefined tasks starting at 50 milliseconds, 100, 250, 500, et cetera, et cetera. If you paid attention closely to the PlantPAx estimator slides, when you set that template up inside the estimator to basically estimate the controller size and everything, it has all of these tasks already built in. And it's assuming you're going to have this much I/O in the 500 millisecond task, this much in the 1 second task, et cetera. So this is consistent with the estimator tool. I don't know if anybody caught that or not, but anyway, is also all the process add-on instructions are already in here. I'm going to be using some of the routines, so we'll get into that in a second. I also, for the sake of the demo, I do have, it's hard to see here, but I do have a couple of I/O modules in my I/O tree that we'll hopefully get to towards the end. But initially, we're going to do everything kind of simulate in simulation type mode. So I'm going to go ahead and jump over to the logical organizer. It's a little simpler for the demo. And so those of you that haven't used this came up in, I think, version 24, where you can basically have a logical organizer that just looks at your code. So, if you don't really care about your I/O tree or your controller tags or whatever. So just to be kind of focused on that. So the first code I'm going to create, basically a simple tank level. So I'm going to have a pump, and imagine just a tank with a level, analog input level. So we're going to start that logic. And I'm going to start it in task D. So task D is my 500 millisecond task. So I'm going to right click, go to properties. I'm going to call this tank 1. Hit OK. Okay, so now I've got my tank 1. So I can open up my tank 1 task. You see the parameters. There is some simulation logic sort of built in here that we'll use. But I'm going to go ahead and add a motor routine or a pump routine. So I'm going to go ahead and add and click on import routine. And there's a short list here in the in the presentation. I think you saw the whole long list. For the demo, we're only going to use a couple of these. So I'm going to click on my my motor, and then click open. So now I'm importing this routine into my project, and we'll just take a moment to do that. And so again, these are the routines that come with PlantPAx. I'm using the standard ones in the demo, so these you guys have access to these. Okay, so we see the screen here, the import configuration screen. So there is a default name, MT100. I'm going to change that to LT100. Oh no, wait, yeah. Yeah, I'm going to go ahead and change that to LT100. And then I'm going to click on tags, and I'm changing the base name of the routine, but I also want to change all the tags. So I'm going to look up here and say, I don't want MT anymore, so I'm going to do a find MT and replace with LT. And then click replace all. And I see here I have 7 occurrences. I'm going to go ahead and click close, click OK. And so now it's going in and creating my new routine with my tag that I've called LT100. And I see it there, okay. And I'm also gonna create, actually, you know what? I probably gave that a bad name, but so now I have my pump, and now I'm gonna create my analog in. Okay. So yeah, sorry about that. So this is actually LT100. Actually, what I really want to call this is tank level. Guess it really doesn't matter. Tank level. And I'm going to click on tags. And yeah, whoops. Okay, this is, I'm going to place XT with LT. Golly. Why don't I do, how about XT with TT? So I know. Okay, click close. I have two. So now I've imported my analog in. So I basically have two routines now. I've got my motor and my analog in. Okay, so let's take a look. Let's take a look at this first of all. So this is my P motor block, and not only is it the block, it's also the full pump routine. And I've got to, oh, shoot. Tell you what, I'm going to, I got a red box there. I apologize for this. Let me go ahead and delete this one out and start that over. This is a little more difficult than I thought in front of an audience. Okay. Let's try that again. Okay, so this is my motor. This is my pump. So really what I want to do here is change this from MT100 to PMP100. So this is going to be my pump logic. And I'm going to change this from MT to PMP. Replace all. Okay, close. And let's see that again. Okay, so let's look at the pump logic. Whoops, that's my main routine. Sorry about that. Oh, I could double click here. Okay, so I'm back to my pump. Okay, that looks better. So I got my P motor here, and again, all this logic is created for us automatically, or already there with the routine. And let me open the tank level. Actually, I'm gonna start this one over too, if you don't mind. Okay, and let's do. Okay, analog in. Okay, so this is going to be level. Level is going to be the name of my routine, and then I'm going to replace XT with LT. XT with LT. Replace all. close, hit enter, okay. Okay, so now I've got my level in my tank logic. This is pretty basically pretty simple. So like what Luis said in the presentation, the next step now is I need to add these routines to my main routine. So I'm going to open up my main routine. I'm going to go ahead and add a rung, and I'm going to add a JSR, and I'm going to find my level, and then I'm going to, of course, you can copy and paste here, and I'm going to paste, and I'm going to change level to pump. There we go. Okay. So now I've got my routine done. So now next step is I want to go download the controller. So I've got a logic emulate running in the background. I'm going to go ahead and click download. And this is when I cross my fingers with the cloud. So we'll see what happens. I'm standing up too for posterity. It looks like we're good. We're downloading data types. Okay, so we're going through, we're almost done. Okay, we're almost done. We're almost there. Okay, but actually by show of hands, who has used the library process objects before in the room? So a handful, not everybody, but some. Okay. So there's maybe about half. So it's a review for half. It's new for some. All right, we're almost done. The next downloads will be quicker. Okay, it says, yeah, I want to go to remote run. So now I'm running. So one thing I think that I've noticed in this demo, that if you guys are interested in playing with it, the way the demo works is from now on, now I've downloaded my first strategies. From now on until the end of the demo, we always leave the controller in run mode. So anytime it changes we make on the controller side, it's in run mode, which is kind of what I would call a requirement of a DCS. And then on the HMI side, you'll see we don't need to stop and start the HMI. We don't need to initialize the development mode or restart the runtime or anything. You'll see that. So the next step. So we've got some code running now. Now it's time to take a look at the HMI. So what I have opened up now is View Studio SE. So this is an SE application. By show of hands, who's programmed SE before? Almost everybody. Very good. All right. So you guys know this better than me, but let me open up the displays here. This is part of the PlantPAx templating system. So you see all of these displays, RA, et cetera, et cetera. So for the simplicity of the demo, we're going to open up our lab screen here. So this is where we're going to be playing on the HMI side. So for the two routines that we brought in a motor, a P motor, and an ALN. The doorbell. Somebody get the doorbell. Okay, so we're going to try to find the corresponding graphics here. Oops, let me open up. So I'm going to open up the motor display. So you can see there's a whole bunch of motor displays here. I'm going to use the pump and drag it over, put it over here, and we've got an analog in. There's a whole bunch of analog ins. I'm going to grab this one. and come over here. Okay, so the next step, after I arrange them for Zachary's benefit. So what do I need to do now? Well, I need to set my parameters. So I've got the parameters in Logix 5000. I need to make them equal. So I open up my global parameters. I click on, I need the tag name. So now I can browse because it's a system. I can go online, and for my pump, after my first misstep, I renamed it Pump 100. Also down here, there's another path. So I'm going to put my PAC-01 path here. Click OK. And I'm going to come over here. And for my analog in, that should be LT100. Click OK and OK. Okay, so now I've got my HMI. I've identified my simple pointers. I'm going to save my HMI. Okay, I know it's saved because the save went away. So now I also have the client running in the background. So notice I made the changes, I've saved, but my lab screen is blank. So instead of stopping and restarting, I just, and again, this is also a PlantPAx template look. So you have standard header and footer windows, then you have a standard development window, and you've got other buttons here. Down here we have a refresh button. So I hit refresh, and there's my logic, or there's my two things I just dropped in. So I'm going to open up the pump, and I've got my HMI here. I've got my wizard here. So I should be able to start this pump, and we should see it running. Starting. Okay, and then the level here is just going to start to dip down in our tank level. So a couple of things. Again, we didn't have to spend a lot of time here developing. All these are standard, and this is 4.5, but 4.5 and 4.6 are the same interface. Notice everything's gray. We've got grays and whites, and that's on purpose. So that's the ISA 101 standard. And we'll get into some more of the configuration, but basically you've got this configured. So, so let's start, I guess, playing around a little bit. So what if I wanted to add some more logic? What if I have tank 2? So let's go back to my studio and say, okay, I've got tank 1. How do I make a tank 2? While I'm online, I say I'm going to copy. And I come up here. I want to paste special with configuration. So I'm copying a running routine, and now I'm going to paste it in a new routine. Okay, so now I've got tank 1. Well, I'm going to call this tank 2 as the base name. And then I need to come over here with tags. So everything is 100. And I've got LT100, PMP 100. So really all I want to do is change 100 to 200. Replace all. And close and click OK. Okay, so now it's about to paste the running controller. So it gives me a warning. It says, you're in online mode. What do you want to do? Well, finalize all edits in program. So, okay, I know it's good. So I'm playing, okay, let's do it. So now it's doing the paste. Right. Okay, so now that was it. That's all it took to recreate that logic, and it's running. and you can see it down here. So we should be good. So now I can jump over to my studio, and again, I can duplicate this too. I've got these separate. What I want to do first of all is group these together, and then do a duplicate. So I'll pull this over here, and then I can do a tag substitution. So again, I just want to replace 100 with 200. Replace all. Okay. All right, so I'm good. So now I'm going to go ahead and save this. And actually, I'm going to go ahead and save my logics too, just in case. Yeah. So that way I've got all my values equal as well as the code and everything. Okay, so I'm saved, I'm good. So now again, I'm back here on the client. So I just hit the refresh, and there's my other tank. So now I can go ahead and start this one, and go from there. Okay, so that's pretty simple. So let's look at some other stuff. Let's look at alarming. So now I've got a running system, and I'm going to open up my my analog point here, my analog value. Or let's look at some of the HMI features. So I really haven't done much yet. I mean, all I had done is just basically have some basic pointers, LT100, PMP100, et cetera. I really haven't defined a whole lot else yet. So I'm going to go over here in the display, and I haven't really touched these. So this is basically what's the display going to look like? Well, I want this to be tank 1 level. Click OK. My label is actually LT100, so I can do that.
And this is one of those things where all of it's getting saved in the controller. So what you're doing at the HMI level is still saved inside of the AOI of the controller. But while it didn't take them very long to put it on the screen, now changing all the little minute details that you usually have to deal with, if you did it in Application Code Manager or you did it ahead of time, you can do all of these edits at the controller level. You don't necessarily have to do it at the HMI, but the goal of all of this is once you're in the HMI, you shouldn't have to open up Studio 5000 to be able to commission your system. And that's kind of what the goal of this.
And correct me if I'm wrong, Application Code Manager, you can set a lot of these parameters too in a bulk level. So this is sort of this is kind of the slow way of doing it, but it's still not that bad of a way. Okay, so you can see now I've got my labels and stuff going. So next step, let's create an alarm point. So maybe I want to take my low alarm and put a real value in there. Yeah, 50. Okay. Yeah, so I'm 0 to 100 here, so I'm good. I should be able to leave that alone. Okay, so I go to alarm, I go to low alarm. And notice how you see this in the graphic, it's gray. That's my new alarm point. My alarm, I just set it at 50, but you don't see an alarm yet. It's because I've set an alarm point, but I haven't actually activated the alarm yet. So the next step is to come over here in my alarm screen and say, this alarm is configured and will be active. So once I click on this and wait a few seconds to go through the cloud, we should see a change in the HMI. And okay, there it goes. Okay, so now the next time this goes below 50, we should see an alarm, if I did it right. So we'll see. Okay, there it goes. So now I see my alarm because it's active. And there's a lot of places to, you know, I can come over here and acknowledge it. I can come up here, I can come down here, et cetera, et cetera. So if I acknowledge it, it's still in alarm, right? But it was acknowledged, so it's not blinking anymore. You know, this is all ISA standard type stuff, but this is all stuff that you don't have to develop, right? It's already there built into how the system works.
You guys notice that when you went into alarm, it showed up in the alarm summary? We did it ahead of time.
Well, I'm gonna jump in. I'm gonna show that a little bit if I have a chance.
Yeah, and this gives you the benefit of being able to acknowledge the alarm from the faceplate. So whatever you do there, because you're writing to the controller anyway, it synchronizes everything. Or you can go to the alarm summary. The other nice piece, if anybody's ever done it at the alarm summary side, is you can set commands on what happens when you double click on it. So it doesn't necessarily mean you want to acknowledge it. You might want to bring up the faceplate, or you might want to go to the screen where the alarm is actually triggered. So those are things that you can build in directly into it. You don't have to worry about where it's coming from type thing.
Yeah, so I'll go ahead and add this alarm to, whoops, 50. Okay. And I have to say, I mean, this is so gray. You don't think it's active, but it actually is. All right, so I'll go ahead and make both of these active alarms. So let's add some more code. Let's roll the dice one more time. So let's say I wanted to add an interlock while I'm online. How do I do that? Well, I'm going back into Studio 5000, and I want to open up my my pump logic. And so in my pump logic, I just happen to know that my routine, my standard routine I'm using, has a whole page just for interlocks. And so by default, you can use up to, I think, 16 or so interlocks, or maybe even more on this. So, but for a DCS guy, this is what he's going to want to do. So how do I do this? Okay, I'm going to go ahead and start a pending edit. And I'm going to go ahead and pull this down. And this is an input screen, so I'm going to go ahead and just link these up. And I know from my little cheat sheet that I've got to have LT100's low status. So I'm going to go ahead and find LT100 here. And I'm going to go down, let's see. And it's somewhere here. There's a few attributes. Okay, here we go. Okay, so I'm good. So, okay, I accept that edit. I say, okay, let's roll with that. I like it. I'm changing pump. That's cool. Okay, good. Now I've made my change. I know I'm green. I'm good. So now I'm going to go back here to the runtime and say, okay, well, wow, what happened? I stopped. I went down. While I was making that change, I was in alarm mode, and I created that interlock, and it stopped me in the middle of everything. So I'm going to go ahead and open my pump up. And I have an interlock screen here, but it's grayed out. I can't get to it. So there's an attribute for that somewhere. And I think it's here. Enable navigation to interlock object. So by default, it wasn't set up that way. Now there's also a whole bunch of security that's behind all this. If you guys have enough patience, we can go through some of that. So now I can enable the interlock. Now at least I can open it up. But I don't have anything visible here. So really what I need to do is I need to add this interlock called tank level OK.
And this is where you build the Lego blocks. So if you're doing it from scratch, you would set up your pump, your interlocks, your runtime, permissives, things like that. Or if you bring in the strategy, all of the blocks are already kind of wired up for you. And when you start seeing, especially on the function block side of it, it's interlock okay, status okay, you just kind of line everything up.
Mhm. Okay, so now that's there. Now I also did check the must reset, but I don't know. I think I'll have to go run through this again before I actually have to reset it. Yeah. So now when I run through this, it'll stop and then I'll have to actually reset it and take my word for it. But anyway, that's how you can add a piece of logic while you're running, adding an interlock. While we're at it, we'll just jump into the alarming a little bit real quick. So I'm going to jump over to the Studio 5000 and a couple of things. So down here in alarms, you have an alarm and event set up. So, okay, it's got to start. So right now I'm kind of blank on alarms. Since I've got 2 tanks, I'm going to create a group called Tank 1, and then another group called Tank 2. And so I'm going to go ahead and group these alarms together. Tank 1, Tank 2. Save it.
If anybody hadn't seen that before, that's a newer feature inside of FactoryTalk View. Before, we had to just go into either alarm class and just write in what our filter was, and you'd have to manually kind of use that drop down. You can now set up little folders and set everything up. So instead of just the alarm class filter, you put them into its own little bucket.
Mm-hmm. And so maybe on this, and this is the frame, the footer frame for my application. Maybe I only want to see one tank there. So I think I can go to properties. And first of all, I want to make sure I get my alarm name listed there. But I'm going to go ahead and browse. And I'm just going to put tank 1 down there. And I want to save this. And I think I'll do this.
This becomes very important as you start growing the size of the system and we start looking at different areas and different HMI servers. You don't necessarily want your operators to have access to everything. Maybe you just want them to have line 1. So this gives you the ability of treating one big application and segment it into little smaller sections. So as they go into that specific area, that specific lineup, that, again, think of it as like the boiler. I'm only presenting the information for that boiler, not everything else.
Yeah. So anyway, so my logic is working now. I'm going to have to go ahead and reset my interlock before I can start over. Notice I was in alarm, but I don't see the alarm down there anymore. It's because I'm only looking for tank 1 alarms down here. So et cetera, et cetera. So that's kind of alarm grouping. Another feature that I thought was kind of interesting was another that's online that who does, when they implement projects, who does late bind on their projects? Does everybody know what late bind means? So up to this point, we've used as kind of a simulation input for our tank level. But let's say we're getting ready to commission, or we're done with our FAT test, and we want to go through we're going to prepare for a site test or something like that. Well, there's a concept called late bind, which essentially what that means is I'm going to take my existing project, but I'm going to bind my IO. I'm going to rebind my IO from a simulated point to a real world point. And so I'm going to go ahead and do that now. So right now you can see down here on my configuration, I've got an analog input in slot 3 of my fake controller. So I'm going to go ahead and go back to the logical organizer, And let's say, okay, tank 1, I'm gonna go ahead and open up my parameters. So all of my, all my tags and all my stuff are local parameters in this task. And so here, my LT input process, this is my tank level input process variable. Right now, I'm connected to tank 1 sim. But let's say, okay, well, I really want to connect this to my real world IO point now. Notice I'm online too. So I'm going to go ahead and click this down arrow. I'm going to go to local 3.I. And I'm going to use the first channel. So I'm looking for my channel 0 data there. Okay. All right. So now that variable is now looking at my analog input card. And actually you just saw it. It went from 100 to 0 right there. So I go back to my HMI and now I'm at 0. Well, my logic just told me that I had an interlock that was going to reset me back to 100. And you just saw me cycle. Well, now why am I at 0? And why can I can't, if I open up this interlock, I can't reset my interlock either. That's because I'm looking for that real world IO and it's out of range. But that's an example of late binding. And I'm not sure when that became available, and that's available for parameters. It's not available for everything in the controller. But if you use the process objects, it's a really nice way to go from simulating a system in your office to a real world system without having to juggle anything, juggle any code or anything like that. You're just basically looking at the system. Okay, a couple more things if you guys are interested. So another thing that comes with these PlantPAx applications is built-in security. So those of you that have done SE applications, do you use like Windows authentication on the apps, or do you use SE security levels and stuff?
Or do you have the little post-it that says operator record?
Or do you not have any security? Yeah. So if you use a PlantPAx system, like this was a template system. If I go down here to users and groups, there's a whole bunch of groups. All these HMIs that start in the HMI, those are all standard groups that are in the template that you can use. So you've got HMI admin, engineering. This is hard. It's kind of hard to see. Operators. All these are tied to specific levels of factory talk SE security. So and there's some. So if I were to go to say operators, and this is a demo, but I've got a couple operators there. So that's where you set up your users and groups, kind of like the way you do it in Windows. But actually in the real time or in the runtime system, you go up here to runtime security.
So in the previous way that you would do it is in factory talk, you would set up your A through P codes. So one person had specific rights. So if you're an operator, PlantPAx would define what an operator code would be, and you just set all of those up ahead of time where they were part of the system. With the newer release, you can now do it as part of user groups and areas. So it's still heavily tied to your domain. So from a Windows point of view, you let IT handle the domain, username, passwords, everything propagates all the way through the factory talk side of it. But now you can set up your rules where it's not specific to the codes. You can actually do it by the type of role that person has.
Right. So and there's a slight update if you've used the older version of I think version 3.5 and older. The default usernames or the default groups took up A through P of the security. Well, they rolled that back, and now I think it's only A through H or A through G. So you do have some other security codes to use as you see fit. But this is an example. This is the operators, and so the operators at level G, And so you can also look at, where was that? Where's the, all the application, anyway. Something else here, I forgot where it was located, but anyway, you can set up all the clicks on the wizards have different levels associated with it. So the home tab, let me jump back here. So the home tab on a pump, that's going to be, anybody, an operator, a maintenance, an engineer, or whatever can access this. The maintenance tab is going to be not an operator, but a maintenance guy, probably an engineer. Diagnostics may be relegated to just engineers. Alarms, you may not want the operators to change the alarms. You may want them the ability to do that, but there's default settings here, but it's all user configurable. And it's all done through the studio interface. So any questions so far? Any thoughts? Was this anything new for you guys, or was it all review, or what? New, okay, well, good. I'm glad it's new for somebody. It was new for me too. But not as new as it was 3 days ago. So anyway, that's pretty much basically all I had. I think it's probably a good time. And again, this same demo is available in duplicates. Hey, thanks for the time.